Welcome everybody to our topic 3, mathematization of nature. I have kept the handout shorter with the precise aim of getting to the end of it. I should definitely be able to manage today, I'm pretty sure. So this is a pretty big topic and also has sort of a number of implications, some of which we'll still be pursuing next week under the heading of Life World. So Life World is going to come up today now and then as a concept, but will not yet really be in a position to think about it fully as to what Husserl really means with his concept of the life world. He uses it in somewhat, like ever so slightly different ways in different places, and that's what we are going to be looking at next week. However, it's basically the world we live in. So life world basically means the world we live in. And as long as you keep that in mind as a kind of provisional, preliminary understanding, you should not have difficulties as such, sort of piecing this week and next week's topic together. I will start a little bit with telling you something about the structure of Husserl's book. And that's not very pretty, I have to admit. One of the reasons why that's not so pretty is because he has these enormously long titles for everything. So the book has a long title, then each part has a long title, each section has a long title. But nonetheless, this is unfortunately relevant and a little bit important. You have it here on your handout. I think the printing on the handout is a bit clearer because the sort of indentation worked out at least a little bit better. The reason why I would want to familiarize you a little bit with this structure is because basically we had already one reading from this book, which is usually just referred to as the Crisis, Husserl's Crisis. We had one reading from the Crisis in week 1. That was the one in big font where he was going on a little bit about crisis and how the sciences don't really give answers to the questions that concern us in our existential being. That was something that was taken from part 1. So I just kind of wanted to let you know, because we have been doing that reading already. This week we are doing this, and next week we are doing this. And so I just kind of want you to be aware that it belongs together in certain ways, even if the page numbers make it obvious that there is stuff in between. So you have at least a sense now what the stuff in between relates to. So just for a quick sort of overview again. So the part 1 is a very short part of the book. And it's indeed just him talking, giving indications about the crisis of the sciences as expression of the radical life crisis of European humanity. And what you want to keep in mind about that is that indeed the crisis of the European sciences for him is a radical life crisis of European humanity. So that's something that we need to keep in mind as we are discussing this this week and next week, because it's just always quite tempting to think, okay, so he's just somehow trying to say the scientists are doing something wrong. So luckily we are doing humanity, so that's okay, that's much better. I sort of hope it can be better in the sense that we can understand perhaps better how things interconnect and belong together. But he's not in any way trying to blame the sciences or the scientists. He's just trying to make us aware that as European humanity, we have given a particular kind of reading to the sciences, and we have started to turn to them for the truth in a kind of fashion that is not as reflective as one would hope. It's not as aware of the alternatives. It's not as aware of where that's actually coming from and where it's going. And that's what he's sort of trying to explain to us, at first in an indicative fashion. Then comes a long part of the book, pretty long part, that's called part 2, and it has the title, Clarification of the Origin of the Modern Opposition between Physicalistic Objectivism and transcendental subjectivism. When you read something like that, apart from the fact that it's again long and bulky, it should also serve as one of those reminders, and we'll get several of those, that phenomenology kind of likes to be in the middle. So we have already seen this about phenomenology trying to stay in the middle between affirming and denying a kind of independent existence of the world and things out there. When we were talking about the epoche, this kind of tendency, this kind of goal or objective to stay in the middle is something that phenomenology has overall. There are quite a number of occasions where phenomenology responds to a kind of realization that being one-sided in one way or the other is not really helpful. Merleau-Ponty, for example, is going to call that quite explicitly the search for a third way, and he is going to run us through one-sided semi-solutions or alleged solutions on a number of topics like the phantom limb, language, sexuality, stuff like that. So just sort of, if you already keep it in mind that the middle way, getting away from the extremes, is something in general that phenomenology likes to do, then you can hopefully also already, in looking at this title, already think that, well, it's probably not really the case that phenomenology wants me to move from objectivism to subjectivism, but perhaps phenomenology wants me rather to be skeptical about visms in general and try to come to something that can sort of give consideration to the subject and to the object, but by first even asking, what is that object and subject? Is there perhaps something sort of more original, closer to the roots than that? And this kind of going to the roots, trying to dig to the most basic, that's in general also very much what phenomenology wants to do. So out of this really lengthy part 2, where he attends to various positions in the history of philosophy, we are only reading section 9. We are only reading section 9, Galileo's Mathematization of Nature. That's the reading for this week. I've already told you many times now that it's a bit lengthy, a bit long-winded. We'll be talking about it in a moment because there are quite a number of important things about the reading. It's the indirect mathematization that he sticks with perhaps the longest, and that's where it also indeed gets a bit tedious. But on the other hand, we do really need to understand what this indirect mathematization is, so that we understand the two versions of mathematization and how Galileo comes into that. So this section 9 is our content for this week. After that, there are still 2 parts to the book, and this again has a long title, The Clarification of the Transcendental Problem and the Related Function of Psychology. There is going to be a part 3a and a part 3b. And our reading for week 4 is going to be from this part 3a, which has an interesting title, The Way into Phenomenological Transcendental Philosophy by Inquiring Back from the Pre-Given Life World. And that is also where the critique of the Cartesian way comes in. So that is now basically important because I told you in week 1 we are going to leave the topic of the epoche behind for a while, even though we haven't yet fully understood what's going on there. So that's something that we are going to get back to a teensy bit today, but much more so next week, because what he's trying to do in this part 3a is to indeed find a way into phenomenology, just sort of collapse all of this into phenomenology, way into phenomenology from the life world. So this is basically his response to the Cartesian way of saying, well, the Cartesian way was a bit too Cartesian for some people, in that we kind of lost track of the world, or at least there was a danger for some people to lose track of the world. So let's do this differently. Let's start our way into phenomenology from the life world. So we'll see next week how he does that. it's a bit tricky because there are going to be various elements that are going to be just basically identical to elements that we had in the epoche, but the way they are motivated and the way they pan out is just a little bit different. So we can definitely learn something about the epoche by looking at it again next week in this new kind of fashion, by placing a stronger emphasis on world. We are not going to do this part 3b at all, so we're just going to skip that entirely. You find that in some introductions, people sort of explain to you at quite some length why that doesn't really work out. So just take my word for it. It doesn't work out too well, although with lots of work it might, but the stuff from the life world is more fun and easier and also connects better to the sciences. And then if you were to pick up the entire book from the library, because some people just sort of like to have the book with which they are working, to also have some awareness as to it being a book and where stuff belongs in the book. I'm certainly not saying you have to, because it was certainly my own aim to put everything on Study Direct that you need. But if you want to have just a sense of the book, then what you find in an appendix called Appendix 6 is the text, The Origin of Geometry. You don't really need to worry about that for now. It just so happens that this text, The Origin of Geometry, became sort of more famous than this section 9 on Galileo's mathematization of nature, because Derrida wrote a very long commentary. So there's maybe a text of I don't remember, something between 15 and 20 pages, and then a commentary of maybe 150 pages or so by Derrida. It's a good commentary. It's, however, very complicated. So I would only recommend it to somebody who happens to already be a Derrida fan for whatever reason. But I just wanted to make you aware of that, because in the literature about all of this, these things sort of come up now and then. So you might think, what is this text about the origin of geometry? Is that the same as the Galileo section? No, it's not. Just simply because Husserl wrote so much, and amongst his 65,000 pages of posthumous manuscripts, there were more things that people put into appendices and so on. Yeah, so this just sort of gives you the structure of the overall big bulky thing from which we are picking little bits and pieces here and there. Okay, good. Now we need to get into why we are even engaging with this material and what we are trying to get out of it. So Husserl is now suddenly going historical, and some people find that very surprising, because when he started off and wrote some of the more technical stuff that we are not reading at all, such as logical investigations, he seemed rather ahistorical. He seemed to be the kind of mathematician who is really not interested in history at all. So to lots of people it came as a surprise that he actually found it worthwhile to undertake historical investigations. And for us that's probably also a little bit surprising, because it doesn't happen that often in philosophy that philosophers turn to history. There was somebody who did that quite famously before Husserl, and that was the German philosopher Hegel, from whom in sort of indirect ways the whole Marx and Marxism stuff comes. Hegel is a very complicated philosopher, so you will not necessarily run into him at all in your studies, or if you do, then it would be sort of during year 3. But Hegel was also somebody who who shared some of these same beliefs, namely, when Husserl says we are heirs of the past, then what is he actually trying to say there? Well, he is somehow trying to express that who we are comes from our past in some fashion. Not, of course, in a sort of direct conditioning fashion, like, oh, because we come out of modern physicalist objectivism, we will definitely all be physicalistic objectivists or something like that. Not in the sense that the past ties us down, but in the sense that what we do is some kind of a response to the past, and in such a way that it also makes sense for us to understand better how we have come to this point where we find ourselves. It is also going to turn out, and this requires, however, somewhat closer reading over the next 2 weeks, it turns out that this crisis that Husserl says we find ourselves in comes as a historical crisis. So it's not something that just suddenly crops up in the 1930s. And this is also something that is important to me when it comes to the overall debate as to whether the kind of crisis that Husserl diagnoses there, whether it is relevant to us nowadays, whether the way in which he describes it and finds it manifest in certain areas, whether that can also be relevant for us now in the 21st century. So that's something for us to watch out for, but it sort of helps with that to think that the kind of crisis that was there in the 20th century, according to Husserl, was not one that came suddenly, but was prepared for since the sort of primal establishment or primordial establishment, it's very difficult to translate that word, of philosophy and the sciences in Greece. So there is a lot more connection in history, Husserl thinks, than what we usually take notice of. So when he uses this term Urstiftung, which is what I've just said is quite difficult to explain, it's not difficult to explain necessarily so much as rather difficult to translate. Some people say primal establishment, some people say primordial establishment, some people say original establishment, and some people say original institution. And somewhere in between that, you can choose which one you like the best. So basically all of these things like primordial or original or so are trying to take care of the ur element in the word, which has indeed something to do with origin or where something originates. And the even more difficult part of the word is the Stiftung, because Stiftung indeed means to sort of instigate something, to get something going, to establish something. But then when you turn that into a noun, it gets more messy in English than in German, because primal establishment of geometry or primal institution of geometry just makes it sound more like a sort of geometry university of some sorts or so, because we often use institution in the sense where it's sort of a bulk of building where something is happening. So try to keep that in mind, that this is something where we kind of want to first figure out through looking at it what is actually going on. But what he means by and large is the finding of something new, the sort of establishment, the instigation, the sort of first finding of something which is new to humanity and then becomes a kind of lasting heritage that people can rely on. And for him, that happened sort of several times when it comes to the sorts of movements that are behind the mathematization of nature. Because the Greeks found some stuff about mathematics, and especially Euclidean geometry, but then Galileo in the modern age also found some stuff. And this, the stuff that Galileo found is what comes under the heading of re-establishment, because there was already an original or primal establishment of mathematics and philosophy and the sciences. And then something, yet again, relatively groundbreaking happened on the basis of that in the modern age. So those are the two sort of movements or moments that we want Husserl to explain to us a little bit more about. But it's just important to keep that in mind, because in his own text he sometimes gets a little bit sort of confusing about it. Talks about the origin of geometry as if the origin of geometry was with Galileo, but the origin of geometry, of course, was with Euclid and the ancient Greeks. So we'll have to see what Galileo's contribution is. And Husserl is going to be very explicit about that. But before we get there, he is sort of trying to explain to us what kind of investigation we are actually undertaking there and how we are going to try and go about it. And he thinks that what we need to understand better if we want to make any kind of headway with a crisis, especially if this crisis has something to do with meaninglessness and not finding answers to existential questions, then it would be really good to sort of see where something is coming from and how it came about, as in what motivated it. And this is, by the way, to my mind, quite a nice question that one can also take and apply to other stuff. So we are certainly going to follow through this now quite closely and see how Husserl sort of teases out the emergence of geometry and mathematics more generally. But let's just sort of for an alternative experiment give you something else that you can think of alongside this thing if you wanted to. Namely, if you think about crisis nowadays, then people have already started debating whether it's a political crisis or an economic crisis. That's an interesting question. We can talk about that in the seminars. It's going to be fun, I think. It's difficult to answer that. If it were to be an economic crisis, then one question that would make sense to ask would be something like, how was the emergence of economics motivated? How did economics ever come about? Which would probably have something to do with the question, how did money ever come about? What motivated the emergence of money? And if you were to ask yourself that question, then you would probably get to something like trading, because money had specific purposes. It was about trading stuff. And that's, again, where the Greeks come in very pointedly. And Husserl, even in a different text, not in the Crisis book, he even thinks that it's possible that the Greeks came up with philosophy because, by way of trading stuff, they got to know strangers or foreigners or alien nations, and that made them aware that the kind of stuff that they took for granted about the world isn't stuff that everybody takes for granted about the world. So it's this kind of initial encounter with strangers, which for Husserl can actually even indeed bring about something like philosophy. And if you were to just kind of keep that in your mind, and then ask yourself what has, however, come of that nowadays, then it's in many ways sort of the opposite, because there is very little contact to actual stuff being traded. There's also very little contact to somebody who sort of can come as a stranger in such a way that their strangeness actually comes out. And instead we are detached from all that and have allowed money dealings, the whole financial market, to become detached from all that. So this, again, I'm just giving this as a parallel example because on the one hand I kind of want you to think about what happened to this crisis, but I also indeed want you to be aware of phenomenology as these kinds of tools that you can apply indeed to other stuff as well. So let's see what Husserl finds out in his investigation of mathematics. So he finds out that there are tendencies in everyday life, or in the life world as he's going to call it, that point in the direction of mathematics. And that is very important to him because he wants us, in a sense, to understand again better what mathematics is actually for. And we will understand indeed better what it's for if we reflect on what it was initially setting out to do, what it was initially meant to do. So these sort of origins and the life world are important for him when he then wants to say later on this week and especially next week, well, we should better have a closer look at the life world again and see how we can actually describe the life world as it is. So in the life world, what we have by way of stuff that points in the direction of mathematics is stuff like measuring the land, measuring distances, creating things in such a way that straight lines and smooth surfaces a lot of times are preferable to sort of clunky stuff. My professor, the professor who first taught me phenomenology, he always had this example of tables, that if you make sort of straight lines on tables, then you can line them up all quite nicely. You can make a lecture hall like this. That didn't quite work out very well. He did it. but we could, we could align it, whereas if it was all crooked, then we couldn't even get started. So it's this kind of very basic stuff that points to thinking about shapes, thinking about numbers, thinking about sizes and distances and so on. So again, this is basically Husserl's answer to the question, where is it coming from? So there is a where is it coming from, and now comes a really important step, because he says, even though we can find these tendencies, as he likes to call it, in the life world that lead to the origin of mathematics, we cannot get directly from the life world to mathematics because they are just too different. There is going to be a leap. And this is something that is quite difficult, actually, I think, to really acknowledge. So try to acknowledge that, try to think about that as one of the major lessons of this text about mathematization. He says stuff like, to explain that, I mean, I will explain that now in 2 steps or so. It doesn't have to quite be clear yet, but it is very important. So he says, quote, fantasy can transform sensible shapes only into other sensible shapes, unquote. So what that means is that if these tables all have such weird sort of shapes anyway. Okay, so if that were to be roughly a square, which it is roughly, and I want this to be a better square, then I can work with this, but I will just still always stay on the level of sensible shapes. I will not really get a real mathematical ideal square on the basis of this thing that I found in the actual life world. If I want to think about a mathematical square, I have to make a leap and kind of distance myself from the life world in some fashion. So, as Husserl would say, even the best table never has the kind of really perfect rectangular shape that fulfills the laws of geometry and mathematics, but instead its shape is merely a type. So the kinds of calculations that you can do in mathematics, where you can, for example, prove that the angles in a triangle come to 180 degrees, I mean, you can really prove that. I think this might have come up at some point in your Kant class, for example. And you can prove that mathematically in such a way that what we do with actual triangles here doesn't matter for that. If we had an actual triangle and we would measure, we would not come to 180 degrees. We would come to, well, if we are very lucky, maybe 179.5, and then somebody would say, actually, I know that it's supposed to be 180, and then the kind of thing happens that happened throughout our school career, I'm sure yours as well, where you just kind of approximate what you actually empirically find on the basis of what you know should be the case, and finished you are. But Husserl wants us to see this leap, see this distance more clearly. And I think this is partly because he is a mathematician and knows that the real sort of mathematical stuff, the ideal shapes, the pure shapes, the exact shapes, they are something indeed quite fabulous, quite fascinating. You can do stuff with them that you can't do with things in the real life world. But the important thing is to not forget about the difference. There is a difference, and we tend to forget about this difference. And forgetting about the difference is part of what makes us think that mathematics can just be applied to the life world without any sort of friction or loss or so. And that's not really going to be the case. So this leap that I mentioned, Husserl tries to explain this leap. And he explains the leap by saying that the mathematical shape, the pure exact shape, is a limit shape that functions as a guiding pole. This is a little bit similar to the substrate X stuff, this sort of unattainable idea lying in infinity, which, however, we change as our perceptual process advances, and that's what we discussed in the seminars last week. So this kind of substrate X is something that is on the basis of the actual perceptual object, and therefore also undergoes changes as we get to know the object more closely. That is not the case for the ideal mathematical shape. The ideal mathematical shape is precise and exact and is not going to change just because I have found in the life world yet another vaguely circular thing. That's not going to do anything to the exact shape of a circle. So to just sort of understand a little bit better what limit shape is, I put a little bit of stuff there that isn't on the handout, so apologies for that. I only sort of realized this morning that I need to give this example. If you take the example of a series of numbers that always gets divided by 2, that always gets halved basically. So you go with 1/2, 1/4, 1/8, 1/16, 1/32. Can already not really say it anymore. But if you were to write that in digital numbers, you would start getting to something like 0.00, and then some numbers would come. So what you have there is a series of numbers that tends towards 0, goes towards 0, but it's not ever really going to become 0, because as long as you have a 1 up there, you can't actually reach the 0. You would only be able to reach 0 if you were to divide 0 by something, but as long as you're dividing 1, even if the number at the bottom gets bigger and bigger, the whole number, the whole fraction is not really going to reach 0, but it goes closer and closer towards 0, and that's what one calls a limit shape. So 0 is the limit shape of this series of numbers that are not, however, going to reach it. And that's the kind of leap that Husserl has in mind when he talks about how mathematics came about on the basis of the life world. So there can be better and better circles. These badges can get better and better, and that's a little bit like a series of approximations. But if one of us wants to talk about an actual circle and say, okay, the mathematical definition of a circle is a line where all the points have exactly the same distance from the center point, that's the mathematical definition, and that's the stuff on the basis of which we can then make mathematical proofs. And we do not find that as such in the life world. We find stuff pointing in that direction in the life world, but we do not find ideal circles in the life world. So this is already something to keep in mind as far as a certain sort of distance there is concerned, which is also going to be important for Husserl's insistence that we try to have a look at the life world in its own right, and not just only at the life world always measured against mathematics. But this kind of measuring against is something that should become a little bit clearer with the later quotes about well-fitting garb of ideas and so on. Okay, now I said leap, and when it comes to making a leap, and also when it comes to Husserl asking about the origin of geometry and how did mathematics emerge in general and so on, then he talks a lot about tendencies and life-worldly tendencies. So somebody might think, okay, he's really going to identify the point for us where there is no other possibility than for mathematics to come about. No, that's not going to happen. So this is one of the things that has to be noted about inquiring into the origin of geometry or inquiring into the origin of mathematics. This is not going to be a strict kind of causality as natural causality would be. I mean, the emergence of mathematics is not as sort of safe as me flipping this off the table and there's a causal law of gravity and so on and so forth. It's not going to be that kind of thing. There is going to be a little moment of sort of wonder or astonishment. There is something happening where we can't quite figure out how come that Euclid wrote a book called Elements. I mean, this is sort of the point where it indeed becomes interesting to do a philosophy of history, because a lot of times when philosophers do talk about history, they're sort of trying to say, well, but it was kind of in the air. Like, people were getting to the point And philosophers also have given some reasons as to how they could come to the point. For example, Aristotle says a certain amount of schole is needed for philosophy. Schole is the term from which school is derived, but schole also means time. So in order to actually do philosophy, you need to have the kind of time that school affords you. You need to sit around in a lecture hall, or not necessarily, but it's one of the options. Sit around in a lecture hall and think about this stuff to really sort of think that, well, maybe there is something to it there that indeed makes it worthwhile to be considered. But if that actually happens, or if you rather make some really fabulous plans for your Valentine's dinner tonight, which could also be a very worthwhile activity for sitting in a lecture hall, is something that isn't really up to me or fully up to you. There are maybe certain sort of changes of attitude that one can facilitate, but whether it actually happens and somebody has a really cool insight or has a really cool idea or so is not something that we can fully understand, that we can sort of fully follow up on by way of saying it had to happen there and then it had to be Euclid writing the elements. We think by way of philosophy of history that if he hadn't, probably somebody a few years later would have written something a little bit similar, or would have had a school where people would have investigated mathematical proofs a little bit similarly. But how it actually happens is something that is not really at our disposal, but it's sort of something that comes under the heading of wonder. Wonder is indeed always a bit mysterious as a response, I acknowledge that, but what makes wonder such a good response is that Plato and Aristotle both gave it, and that almost never happens that they agree. And then Husserl and Heidegger also both agreed that wonder is very important, and that also almost never happens that they agree on something. So we have four major philosophers who think that wonder is really something worthwhile thinking about when it comes to the emergence of philosophy, but also the emergence of the sciences, and these kinds of ways of theorizing and taking a distance from the world indeed kind of came up together, but in slightly different ways. Okay, so we'll inevitably be talking about wonder again, because I just can't help myself. We'll be talking about moods with Heidegger, because it's in general also quite interesting to think about the sort of stuff that isn't really in our control. Okay, so so some question marks around the actual emergence of mathematics. But what is it now that is happening when it comes to the mathematization? So, geometry originated. Geometry originated with the ancient Greeks. Now comes the mathematization of nature that happens in the modern era. And that's sort of where the contribution of Galileo slowly comes in. But what we owe to him is something that actually sort of requires a distinction. And this distinction is one between direct and indirect mathematization. And it's a little bit tricky, but if you actually sort of, once you understand it once, it's really not that tricky anymore. And perhaps even sort of more straightforward than Locke, whom you were discussing on primary and secondary qualities in early modern philosophy, I'm sure. So, what Husserl is trying to explain to us is that if we're looking at spatial shapes, we can mathematize them directly. So we can pretty directly say, this is a badge that has a circular shape and has a diameter of 5 centimeters. Sorry, can't do this possibly in inches, but close enough. So whenever measuring happens, there's some kind of a unit in which you measure stuff. And for spatial shapes, you can do that directly. But for other stuff, which somebody like Locke called secondary qualities, you cannot do that directly. You can only do that indirectly. But luckily, you can do it indirectly. So in that sense, it's not really a problem. It just removes you further from the life world, which is worth noting. So examples for these sort of things that can be mathematized indirectly are color, warmth, weight, hardness, and so on. And they are mathematized by virtue of their relation to the spatial qualities. So there are a number of examples that work quite well. Oh yeah, let me however first, so one of the most confusing things, I'm afraid, about all of this is the expression planar. So this text is a little bit permeated by the expression planar. The translator, David Carr, he's a very good translator, but I'm not absolutely sure why he went for this expression planar. The literal translation of the German would probably have been something like fillings. And fillings is quite good for color, because color indeed fills the mathematical shape. It's a little bit more difficult to see how some other stuff like temperature or so could, I mean warmth for example, how that could qualify as a filling. Sense qualities could be the best thing for your own purposes to just sort of think of that. So if you see this term planar, you need to probably initially in your head either replace it through something like sense qualities, or you need to sort of remind yourself of the different examples. And then when the term planar doesn't look so weird anymore, then you know that planar is just always the stuff that goes through indirect rather than direct mathematization. Indirect mathematization works, for example, if you take the case of music, and that's the example that Husserl indeed gives us, because the pitch of a tone is directly related to the length of the string set that is vibrating. So, you know, if I have a longer string, bzz, the sound comes out a little bit differently, and I can measure all that. And something very similar happens with temperatures. So if you want to measure temperatures, all you need is a thermometer. A thermometer works by way of having a glass little cubicle of some sorts with liquid in it, and this liquid expands in a regulated fashion in accordance with the temperature, and so you just put lines on it and call the kind of thing where water freezes maybe 0, or if you calculate in Fahrenheit then maybe not. So it's just a matter of sort of finding the right conventions and putting the right lines. It's indeed this regulated fashion that is good and helpful, and that can lead to the idea that Galileo had, namely that this kind of mechanism of indirect mathematization can be extended through the life world as a whole. So if we have not just direct mathematization but indirect mathematization, we can really mathematize everything. And that's basically still, I think, the path on which we are, and have made it even more complicated by looking even into brain structures with stuff like that. So Galileo's contribution was the idea that there is a universal inductivity such that the entirety of nature can be described mathematically. And because of that, Husserl says, Galileo is at once a discovering and a concealing genius. That's something that we want to understand. By the way, this is the week when I would like you to bring questions to the seminars. I will email you once to remind you, because we are now always taking this in turns. So 1 week you bring questions, 1 week I bring questions. This is the week when you bring questions. This would be one, but we are already going to start talking about it a little bit. But what we definitely want to understand in the seminars also better is, in what respect is Galileo discovering, in what respect is he concealing? Well, he's discovering because this is indeed an interesting discovery, that there are all these regulated ways in which sense qualities can be traced back to spatial qualities. But why was there something concealing there? Well, one of the reasons why Husserl calls Galileo also a concealing genius is because the enterprise of the mathematization of nature became so influential that other ways of relating to the world kind of became covered over by it. And again, this is something we want to understand better as to why there is a problem there. But part of the problem comes from the fact that objectivity is so attractive. Objectivity is attractive because it, well, equates with subject irrelativity. It's something that we can indeed sort of try and explain to people at all times, regardless of their backgrounds and languages and so on. So, you know, if we discuss the temperature in this room, it's quite possible that we could get into a heated discussion where some people would say, it's really too hot here, I'm just falling asleep. And somebody else might say, no, 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 it's really too cold. I cannot focus because I'm almost shivering. And we cannot really get out of that because there is nothing really that you can say to somebody who says, I'm cold. I mean, it's one of those very basic realizations. Plato also says that in one of the dialogues in the Theaetetus. You cannot really argue against that. You cannot say to somebody, no, you're not. But if we find an objective measurement, then this would probably end up with something like, well, this lecture hall doesn't have that, but normally they have this little box here that already gives some kind of a number, like 20 degrees. So if we had a discussion like that, I would wander over here and I would say, oh, it says 20 degrees. That's most likely. That seems to be sort of average and standard for a lecture hall. And this thing seems to be working, so we should all be sort of fine. And I can, in some sense, take that to override your feeling of too hot or too cold. Although it doesn't take it away, of course. But it is a good way of reaching some kind of consensus amongst people, because you indeed get something to go by that isn't subjective and that isn't dependent on how you understand warmth and what kind of a creature you are and so on. So there is definitely something quite attractive there, you know, also for all sorts of discussions, if you can name it in such a way that it's objectively true. But what Husserl says is the tricky thing about this attraction of the objective is that we then really think that this is the truth in like all respects and for everything. So he says, we measure the life world for a well-fitting garb of ideas, the so-called objectively scientific truths. And that means that we would then not really even quite be looking at the life world as attentively anymore and sort of try to perceive what's actually happening, but we would kind of believe what the newspapers and the science books and so on tell us about it, and would think that the sciences give us the truth. And they give us some truth, but the question is, are there other truths as well? And one such example, I mean, this is something where I have already found, I think, that the English education works a little bit differently from the German education. If I say space, and I ask you to imagine space, then the impression I get is that you do not, with as much likelihood, see this and just this in front of your eyes when I ask you to imagine space, but probably some of you will. So this is what Descartes basically taught us to imagine when we think space. Descartes thinks that space can be thought by way of three axes that have this very lovely feature that we have right angles. They are all around, and then we can have units, and we can mathematize and measure everything as we like it. But what we don't really get out of that is, for example, the difference between this, this, and this. And this is something that Merleau-Ponty said was very important, because he says, as embodied creatures, depth is a particularly enigmatic dimension to us. Depth means that stuff gets hidden, gets eclipsed by other stuff, because I am here with my body, and my body is a constant here. So what's right there, I can actually not really see, because it's eclipsed by all of this stuff. So you can see it because you have, from that perspective, more access to it. Whereas something that is sort of 1 meter from me over there is all quite accessible because it's not hidden by way of depth. So from the sort of perspective of an embodied creature, this is not really true. It's not really true that all the dimensions are the same. There is a dimension that goes away from my body, where things are more enigmatic than in the other dimensions. And those kinds of things also sort of would hold true, for example, if you describe art. You know, if you describe paintings, then you also get a truth that is quite different from the mathematical scientific truth. Because if there's a painting here on the wall, somebody might say, okay, it's like almost a meter long or so. That's true. But in the painting, there could be the space of the Swiss mountains or so. And they are definitely, they have a different, very different spatiality from less than a meter wide. You know, they have an enormous, sublime spatiality, and the painting could, in some sense, show that in a way that is sort of similar to the difference between perceived time and objective time that we were already discussing before, or the way in which my glasses, if I'm not aware that they are on my nose, they might end up being sort of further away from me than the stuff that I can handle and know where it is. Okay, so when we will be discussing this in the seminars, please bring questions. Please keep in mind that what he then sort of concludes about the life world is that there is a kind of essential indeterminacy in the life world. So the fact that we have indeterminacy and ambiguity in the life world, but have purity and objectivity and exact shapes in mathematics, is basically just something to acknowledge. You know, it's not something where we would say, we want to get rid of mathematics. No, not at all. But we just want to understand better what it can do and what it cannot do, and how it is somewhat distant from the life world. Thank you very much.